So I thought it was a great place to stop yesterday at 8 so that we wouldn't forget about how to find the holes and the vertical asymptotes and the horizontal asymptotes before we got to the graphing stuff. So take a look at number 9. Do we need to factor? Cool, it's already done for us. Wow, that was nice of them. We have a hole. Where? X equals -1, exactly. This would cancel, so it would be, let me write it over here so I'm not writing over the top of the original problem. That would cancel. So at -1, we have a hole. So, do we get a vertical asymptote? Where is it? X equals 3, yeah. Always the denominator. Always start with that denominator and say, what would give me a 0 down here? So x equals 3. And again, it has to be x equals 3 because that's the equation for a line. Alrighty. Horizontal asymptotes. Now we have to think, if this were all multiplied out, what would the powers be? Well, that one would still be x plus 1 up there. That one would look like that. If that's the case, do we get a horizontal asymptote? And if we do, what is it? Is it y equals 0? Go through your list. If the degree of the top is less than the degree of the bottom, it's y equals 0. If they're the same, what do? Funky little fraction thing. And if the top is bigger than the bottom, then what? Don't get one. Yeah. So just, like I said, memorize those 3 things in a list and you'll be just fine. All right. Now we're going to use that information. Notice the same stuff has to be found that had to be found for number 9. Let me scroll this up a little bit so we can see the whole problem. That's where we start with that good stuff. So, do we have to factor it? Oh, good. It's already factored. Do we have any holes? Yes or no? Holes? Yes. This. Wherever there's an X, there's an answer. So, where would the hole be? Not 1. 0. Remember, we're talking about the denominator and the number it can't be. The number it can't be is 0. So does that leave us with a vertical asymptote? Is there something else in the denominator? So where's that vertical asymptote going to be? X equals 3. Think about multiplying it out. So does it have an asymptote? And if it does, what is it? Y equals 0, exactly. Degree of the top is less than degree of the bottom. Y equals 0. Now this is where we stop and put on that stuff, because that's the stuff that's not supposed to show up on a graph. So we go ahead and go to x equals 3. 1, 2, 3. Graph that asymptote. Y equals 0. And now here's the little bonus thing. And that would be, if I want to know where that hole is going to go, I go over to this canceled out fraction, where I already canceled the x's, and I put the 0 in, and I find out 0 what is where my hole is going to be. So if x equals 0, this is going to say 1 over 0 minus 3, which is -1/3, because that hole has to be on my graph. So I've got to go to 0, -1/3, and make a big hole right there so that Cedar Home can see it. You knew, hey, there's a hole there. You have to have that on there. Now, the other way to do it is to graph it with your graphing calculator and then remember to put a hole at x equals 0, but most people don't do that. Most people forget by the time you get down there. All right, I'd like some points that are on this graph. So I would love to find the x-intercept and the y-intercept, if at all possible. So how do we get all the information we could from the bottom of this fraction. So we're done with the bottom. Now we go to the top. Is there any magical way for us to make this 1 a 0? We're not going to get one. We won't get an x-intercept. Can't happen. If there's no x left up there because it canceled out, there's nothing we can do. But the y-intercept, maybe, just maybe, we can get one of those. Take a peek. What do you think? You should cross off everything that would have x's in it, and let's go up to this one because that's the easiest one. You just get 0. That's it. Well, we know we can't use 0. That has a hole in it at 0. So that one's worthless. So why weren't there spots on this test for the x and y intercept? Because they were worthless. That's why. So we really just grab the graphing calculator at this point and we see, hey, what does this thing look like? So I suppose I better grab some graphing calculators while you guys are using yours. Alrighty, now it's up to you, but the easiest one to punch in is going to be the one where we went ahead and multiplied this out, the x over x squared minus 3x. Add some space for that. One set of parentheses for the numerator and one set of parentheses for the denominator. And on this one, you wouldn't need them on the top, but it sure doesn't hurt. X divided by x squared minus 3x. Zoom 6. Now, I'm really hoping to see error at x equals 3. Second graph. Oh, look at that. At 0, there's an error. It's telling us about our hole. That's kind of nice of it to do that. And at 3, there's an error. So that's good. That tells us, hey, our hole was correct and our vertical asymptote is right. So then I think, okay, what do I really need? Well, I probably should take a look at what's going on at 1 and negative 1. That would give me a couple of points. And then I probably better see on the other side of 2 what's happening. So 3 and 4. So up there we see that at 1 we have a negative 1/2. At negative 1, a negative 1/4. And you could write the decimals down. For graphing, it doesn't matter. There's decimals or fractions. 3, we see our error. Oh, that's a good thing. Oh, I should have chose 4 and 5 then. I guess I keep thinking it's always great to check that your asymptotes are where they're supposed to be at. So we've got 1 negative 1/2. Right there. And negative 1, negative 1/4. And because we saw it, and because we know what it does for asymptotes, it gets closer and closer but never crosses. We're going to carefully leave that little hole right where we know it's supposed to be. And then we have 4, negative 1/4. And 5. Oh, I wrote over the top of something. There was a positive one there. Couldn't have been. Yeah, 5 positive. 4, 1, 5. There you are. And make sure you put arrows on it. And then it's kind of off a little bit. here for a domain range, any of that, because it's not like you didn't do enough work by getting all that good stuff on there. So there it is. 11. Looks familiar. Looks like that. Remember that was one of the things I said you have to memorize. You know, inverse is division, y equals k over x. That is our generic hyperbolic standard form, y equals a over x minus h plus k. And then you have to memorize that stuff about the horizontal asymptotes. So, this can't have a hole in this form. In this form, there's no way for us to have something that's going to cancel on the top and the bottom, so that's going to be enough. But there definitely is a vertical asymptote. Where is it at? X equals 2. How about a horizontal asymptote? Where is it? Take a look up here. There's a number that needs to be dealt with that hasn't been dealt with. 1. Y equals 1. Well, that's the stuff we're not supposed to graph. Now, if you're saying, Cedarholm, you forgot about the horizontal asymptotes. No, that's that number back here. So here's vertical, right here. Here's horizontal. This one, you don't need to do the whole degree thing. You don't have to look at the powers to see it. It's right there. That's what it is. So x equals 2. And y equals 1. And maybe we're going to get an x and y intercept with this one. But, you know, kind of looking around, I don't see a slot for x and y intercept. So maybe that's supposed to tell us we should just grab a graphic calculator and find some stuff. So if we try 0 and 1, those should be pretty good. And so should on the other side of this little 2, so 3 and 4. Should give us a good look at this. But remember, you have to put parentheses around this denominator and around that fraction so the calculator knows to do it. Do that division. Actually, it should do that division from left to right. So you might be able to get away with just the x minus 2 in parentheses. Let's see. I'll try it both ways. Parentheses divided by parentheses, x minus 2. Parentheses, parentheses, plus 1. And 3 divided by parentheses, x minus 2 parentheses. If we only see one graph, then we know it doesn't matter. Doesn't matter. It'll give you the same graph. So if you just put parentheses around the bottom of that, you'll be okay. Then, second table. We're hoping to see an error at 2. So at 0, we're supposed to get negative 1/2. And at 1, we're supposed to get negative 2. Well, that looks good. Because that fits right with our asymptotes. Nice little hyperbolic branch right there. At 3, we're supposed to get 4. And at 4, we're supposed to get 2.5. And that fits right in with our other asymptotes. So again, if you accidentally draw over the top of your asymptote, you erase it. You know, like this part over here, this is too close for comfort. My blue got too close. So I would do that again. Because that shows that you understand it's going to get super close to that asymptote, but it's never going to cross it. That's a big deal. So did we have an x-intercept and a y-intercept? Well, yeah, across the x-axis right here, across the y-axis right there. But we didn't need it perfectly because we had our branches. So there it was. This is just like the test. So take a second look at it. If there's anything you want me to make another one of, I could certainly do that. So if we took the test right now, 43210 me on your confidence level. Oh, and I guess it's a good thing we're not going to take it tomorrow, huh? All right. So here's what we're going to do. I am going to get you the assignment up here, and then we have a little quiz on Schoology, a formative quiz to take on 8.1 and 8.2. So it's one more chance for you to see the variation stuff and this, y equals a over x minus h plus k, and give it a try before you take the test. The formative quiz is just that, it's formative, but don't race through it. You've got a test tomorrow, so see if you can do them all right. So let's see, you need homework assignment. There it goes. It just took its sweet time. Oh, that's not there. There it is, split test reviews. Oh, that's really big. Okay. So I gave you the book chapter test yesterday because the answers to that are never in the back of the book. So I could show you the transparencies. But the review answers, those you can check in the back of the book. Usually all the review answers are back there. So you're going to want to do 1 through 10 and 13 to 22. Make sure everything goes well. We will have time for a few questions tomorrow before we take the test. But write this down and then grab your Chromebook. And I am going to enable that little Schoology quiz. It's 6 problems. Maybe grab a piece of scratch paper. You've got calculators, so scratch paper and calculator, and